Hello, this is Lucas from Wilger Industries here in Saskatoon, Saskatchewan, Canada. Just here to kind of walk through kind of an example application or spray tip selection for an application of 5 gallons an acre. Glyphosate for a pre-burn application or a pre-emergent application with a Pulse Width Modulation spray system. For an example, we are just in our wilger.net website, to which there's a tip wizard application there. Alternatively, there are versions for smartphone applications or tablet applications that are free for use as well. So we will start off with selecting US gallons an acre, just as the intended application unit. We'll select the Pulse Width Modulation spray system. So for an example, those are systems like Capstan Evo, Capstan Pinpoint, K-Same Command, or Command Pro, or Command Flex, John Deere ExactApply, or even Hawkeye, IntelliSpray, or others that might not be mentioned that modulate the physical flow of the nozzle through a secondary means with the function of keeping the spray constant through speed ranges and such there. For the search function, we'll use search for spray tips, being that we have the application known. We just want to find the best nozzle for the job. For this example, we're going to be using 5 gallons an acre, so 5 US gallons an acre. For travel speed, we'll say 17 mile an hour. In this example, I just use K-Same Command Flex just as the option. The reason that Pulse Width system is listed as a drop-down menu is not because anything's tracked. It's more so as different Pulse Width systems often have different pressure drop through the solenoid, just to give you more accurate results. Systems. For nozzle spacing, we're assuming we're on 20-inch spacing or 58.8 centimeters for some of the metric folk. If you have alternative spacing, same idea. If you have 15-inch spacing, just plug it in. Tip Wizard is really good in keeping that custom chart available for you. For the spray tip angle, we're using 110 degree spray tips. 80 degrees were historically used more so when you were on a fixed boom sprayer or a lot slower applications with 15-inch spacing or some factors that might have changed which angle of nozzle to use. For this target spray classification, a few different things you can put in here. So you can select something like coarse, again, depending on the chemical label application. For glyphosate, you might, depending on region or country even, you might see something like coarse, requires a coarse spray or a medium spray at the very minimum. Alternatively, something Wilger does a lot more is uses a droplet size. So the VMD or the droplet size is not intended to replace the spray quality whatsoever. What it is more so is an extra filtering tool. So if you're more familiar with Tip Wizard or the nozzles that Wilger makes, you can use that to really filter out a lot more of the options, giving yourself better results just in the tip search. So what it also lets you do is that it lets you set your benchmark as far as that droplet size. But if you have more sensitive conditions, it lets you augment that droplet size a lot easier than going from one spray quality to the next. For an example, if 400 microns is a reasonable spray quality for somebody in Western Canada where a lot of broad acre farming is done, whereas somebody who might be in Eastern Canada where there's a lot more smaller fields, a lot of urban spraying, a lot of waterways or environmental concerns, that there would be reason to go to a larger droplet size or a coarser spray, because with coarser spray there becomes less particle drift. Particle drift being, the spray that might go off target and hit something that's not intended to. Please note there's the disclaimer here, so all the information here is extrapolated based on testing of water without active ingredients in very controlled circumstances. But real life conditions do change how the spray dynamic and everything else works too. So please make sure you check that. A few different nozzles, given we've inputted our application information. A few different nozzles show up in the results. The first one being the DR11003, the DR being the series of nozzle, 110 being the angle, and then the 03 designating the ISO flow. So 0.3, so 03 being 0.3 gallons per minute flow at 40 psi. That number is very useful when you're calibrating nozzles, just to make sure that they're actually flowing as they intended to which in this case the 04 should be putting out 0.4 gallons per minute under your spray boom at 40 psi, given that minute check or some multiple of. So simply enough, with these results, they are sorted from smallest to largest, not necessarily best to worst, just so you're aware. We'll start at the beginning here just to make sure we're sizing our nozzle appropriately. With the nozzle size, it is important, but not the most important part of the spray application. We just want to make sure that nozzle size is going to be able to give us the rate that we need for pretty much the intended application pressure that we'd like to run at. In this case, the DR103, you'll pretty quickly see in these first 3 columns there's a fair bit of red being, a warning sign. We can see pretty clearly at 35 psi, our speed range can only go to 16 mile an hour, to which our duty cycle, if we were wanting to go 17 mile an hour, it has to be over 100% duty cycle, which isn't possible. So in this case, this nozzle is restricting the flow, so we can't put our full flow out. Even though, again, most operators might not be operating below 30 psi, which is fine, because again, you don't want to be too low, we still want to pick the most flexible nozzle possible. So we'll discount the DR103 strictly based on size before we look at anything else as far as the spray quality or any of the other charts there. So we'll minimize that. Before I go ahead, there's 2 buttons on the top side on the web version of the TipWizard app. One being a printer, to which it'll open up a new page, which will have a customized spray tip chart for your exact application. And then there's a star. The star just favorites it for the next time you go into the app. You can pull it up pretty easy. But the print icon is quite nice, especially for first-time operators, just because you'd be able to print it out, have it in the cab, so you have a personalized spray tip chart for your actual application for your travel conditions, so that it doesn't have any noise. You have all the information at your disposal. So I just wanted to make a note on that. So this is the MR104. You'll notice there's another red nozzle here, the DR104. So the DR series is the next coarser series in the MR series. So even though the flow rate is the same, they will be very different in terms of what kind of driftable fines as well as coverage they produce. In this case, the MR103, the green line here is where the droplet size is closest to where we searched. So we searched for 400 microns. Again, not necessarily the be-all end-all. We still want to make sure the classification is valid for a chemical label. But for simplicity, we'll use 40 psi. For our example, to which we can travel 5.7 to 22.9 mile an hour. On the bottom side of things, so that 5.7 is your minimum duty cycle at 25% duty cycle. Again, we do not want to typically operate at a duty cycle that low. On the flip side, on the max speed side of things, that's where 100% duty cycle is. So 22.9 mile an hour. In our example, we selected 17 mile an hour as our max speed. So you might wonder why we might even want to have it a max speed that high to 23 mile an hour. And the reason being is that we want to ensure that we have flexibility. So flexibility in our ability to operate the machine, avoiding obstacles or keeping applications more consistent, and generally taking advantage of turn compensation mechanisms within the sprayer system as well. So even though our travel speed is only 17 mile an hour max, that's our travel speed at our center rack. So given the right at the center of the sprayer where our speed is the most consistent, it very quickly will change though as soon as you deviate from straight. So if you're turning around an obstacle or a slough or a waterway or whatever the case, very quickly the outside wing of your sprayer is going to be traveling a great deal faster than 17 mile an hour. This extra room that you have on the max speed side of things, that's going to be what extra flow capacity is at your demand to try have a cleaner application into those non-straight vectors. So 74% duty cycle is just the percent of that duty cycle at your max speed. As far as a rule of thumb, a good place to be is, usually around that 60 to 80% duty cycle. The reason it is more of a range rather than just a single number is because there's a lot of leeway. So typically there's not much penalty for operating at a little bit higher duty cycle, a little bit lower. There's typically only 2 penalties. So penalty being, trying to be over 100% duty cycle or literally maxed out. At that point, you have no flexibility left, or you're under rating, which is, again, not good. On the low end of duty cycle, if you're below 50% duty cycle, typically even more below 40% duty cycle, there can be issue with the operation as well. So below 40% duty cycle, you can imagine every second nozzle they're working in pairs. So they're pulsing in pairs in each other's off cycle. If your duty cycle is ultimately too low, for an example at 5.7 mile an hour, we're at a 25% duty cycle. So one nozzle is pulsing 25% of the time, and the next beside it is 25% of the time in the off cycle. The troublesome part is that if you add those two together, you're only spraying half the time. So what you can end up doing is you can end up getting checkerboarding. Again, not typical for most applications, especially if you've picked the nozzle correctly for your application requirements. But that is the penalty to having a duty cycle that is too low. In this case, though, again, being above, just at 74%, no issues there. We're happy because, again, we have 26% more flow capacity we can put out without changing a thing. So simply enough, our first step of selecting any nozzle, whether it be for this 5-gallon application of glyphosate or otherwise, we'd want to start at the first 3 columns here. So the pressure, speed range, and duty cycle. So the pressure being, that's the gauge pressure. So that's the sprayer pressure in the cab. TipWizard accounts for that pressure drop at the nozzle through the solenoid. It just doesn't show it in this application. But nonetheless, 40 psi at 17 mile an hour, we have no downside in the sizing. So that effectively this 04 size, whether it be the DR or MR series, the size is satisfying our needs. That means we can go to the next step, which is qualifying the spray tip. So qualifying the nozzle, making sure that, first of all, it is within label requirements. So being at 40 psi, we're in the coarse spray quality, satisfy the requirement. The droplet size, again, is there more so that you have a relative factor of coarser or finer spray if you do choose to use your system a little bit more and change that pressure on the go. So if, for an example, in typical conditions, we want to try be around 40 psi to have our droplet size close to that 400 microns. If conditions are optimal, so an ideal spray day where you have a troublesome spot in the field that you do have more greenery or you want to have a little finer spray, that's when you can press a button in your cab, you change your pressure on the go, and you might bump up your pressure. So you still want to make sure you're following the requirement of the spray chemical label, even at any operating pressure. But nonetheless, we'll qualify the spray tip at 40 psi, as that might be our typical application requirement. The next 2 columns are where it becomes a little more interesting. So the first column here you see is the percent less than 141 microns. So you can think of that as your percent of driftable fines. Again, in ideal conditions. In ideal conditions, that's meaning where you just have a gentle breeze, nothing too crazy. Conditions are overall just good. The best you can assume in the field. Where that is important to note, if your conditions are not ideal, as in the wind is picking up and that kind of stuff, this driftable fines factor can be useful in planning out your spray application as well. So for an example, at 6% driftable fines, so that's 6% of your total volume of chemical and carrier, you can effectively write that off, whether it be written off due to evaporation, being blown off target, due to wind speed, travel speed, or pretty much any factor that's taken it off target. And it doesn't matter whether it's 5 feet off target, 50 feet off target, or 500 feet off target. The intent is that you use that as a factor of knowing how much general tolerance for drift might be. When it comes to less nice conditions where wind is picking up, for an example, at 12 mile an hour, you might assume that driftable factor might double, just to give you an idea of, okay, when do I shut down my spray application? As far as a rule of thumb for glyphosate or other systemic applications that might rely on a pretty reasonable level of coverage, typically want to try to keep that below 10%. With some more restrictive chemicals where you want to be far below that, whether it be 5% drift or less, or some being, even sub 2%. Nonetheless, for glyphosate, being within 10% is pretty reasonable. At this point, we're at 6%, which is a pretty darn good place to be in terms of drift, especially given we have a pressure range that we can drop to reduce that driftable fines more. Another note is that driftable fines number, it's not including any other means to reduce drift as well. So whether you're using wind curtains, which obviously would reduce drift, slower travel speeds or adjuvants, those are all practices that do change the physical percent of driftable fines. But TipWizard, again, we want to give you the brunt of the water rate where everything's equal. You can start there anyways. So we want to try to keep that within 10%, or we do not want much drift. The next column here, so the percent less than 600 microns, you can kind of assume to be a level of coverage. So any droplets that are larger than 600 microns are just typically less effective due to typically 2 reasons. Being the droplet is large enough that it might hit a leaf and roll off and do nothing for your application, other than maybe ground applied or soil applied applications. Nonetheless, it's just not as effective. Also, it chews up a lot of the water or the carrier volume or chemical volume to make up those really large droplets. So in that way, it's kind of a relative level of coverage, if you want to think of it that way, with the intent that at 40 psi, 88% of our chemical or carrier is pretty well sized to be reasonable for coverage. The 12% that is coarser than 600 microns, so right there we have 88%. The other 12% is still coarser. So that stuff we can almost not so much write off, but it's just not an effective volume of our chemical. Given this application of glyphosate being a systemic application, since there is less need for coverage compared to a strictly chemical or contact acting chemical, typically a decent rule of thumb might be trying to keep your percent less than 600 microns above 80%. So being above 80% would kind of give you enough coverage to do a good job. At this point at 40 psi we're at 88%, so we're well above where we'd like to be. More importantly, well above where we'd like to be in coverage while still maintaining a relative level of drift that's acceptable to us. Again, what's acceptable to you will definitely be determined by your field conditions because, well, I'll put it this way, you know your field better than I do. But nonetheless, using that rule of thumb and just that relative factor of drift, you can have a pretty good idea what might be okay for your field. Another thing, and this is kind of more of a tip, to use both of those factors when you're coming to compare two nozzles side by side, you can take this percent coverage or percent of small droplets or useful droplets, whatever you want to call it, you can take that, subtract the drift. So 88 less 6% driftable fines, and what you're left with is the spray that's in between. So the stuff that is nice and fine, but not too fine to drift, or drift in typical or ideal conditions. What that can give you is a number. So in our case, it'd be 82%. So 82% of our spray volume would pretty well be effective for what we're wanting to do. What we can do with that now is that we can use that to compare with another nozzle. For in this case, we'll go to the DR1104 at 40 psi, just for apples to apples comparison. The spray quality and such are coarser because it is a coarser nozzle. Our driftable fines is down to 4% compared to the MR series at 6%. So right away we see a clear indication that yes, the drift is lower, would be expected to be lower with that DR1104. However, you'll see a stark difference in the coverage factor. So 88% coverage with 6% drift, we have 82% effective spray. Even though that DR cuts our drift down by a third, from 6% to 4%, the cost of that 2% drift savings is pretty heavy. So doing the same math on this one, 74% coverage, less 4% drift, we're stuck with 70% effective spray volume. When you're comparing two nozzles, as long as the driftable fines is still reasonable for your application, you'd be pretty confident in whichever nozzle has the better factor of effective spray. So in this case, the MR1104, giving 82% effective spray at 40 psi, would probably be the better option for most applications. Again, if you have systemic applications that they're very sensitive to drift, that's where you might opt, even though there's a lower level of coverage. Often that's the case where you'll find higher water volumes required by label to help compensate for that requirement of very low drift. But in our case, the MR1104 at 40 psi is probably the ideal choice, not so much just because the relative level of drift is low and coverage is good, but because it also gives us flexibility. So the flexibility being either dropping our pressure on the go, so even down to 30 psi in extreme cases, we're still kind of keeping a decent relative level of coverage, which is still above 80%, which for systemic application was kind of our rule of thumb, with driftable fines being around that 4% as a benchmark. On the flip side, if there's an application that requires a little bit finer spray, we do have that means to bump our pressure up on the go, since the pulse width system will account for that just based on the duty cycle. So for an example, even at 55 psi, we're at a 63% duty cycle, which is still fine. Our spray quality has not changed at course, but our droplet size has gotten finer, which is expected. Our drift goes up to 8%, and our coverage goes up to 92%. So that's where that relative level of coverage, there's some extra coverage gains that are available if the conditions allow. So that's why the MR1104 might be a good option. Alternatively, we could go to the next nozzle size just to verify that this is where we want to be. With the SR105, we might say well, we'll do 440 psi. Our duty cycle are lower than the other one, whereas it might just mean we're typically having to keep our speed up a little bit more. But you'll notice pretty quickly that our drift is at 10%, which is kind of the top end of what we used as our rule of thumb for this situation. But our coverage factor is at 93%. So this is a good example of if that coverage factor is high, but our drift is probably unreasonable, that might discount this SR105 from being used and still be in favor of this MR104, with the reasoning that we can be more effective consistently with the MR104, because if that drift factor doubles, for an example, in our case, if the wind picks up, if that doubles and we still want to try keep within 10% spray drift, we have that means even just by dropping to 35 psi. With the SR105, we do not have that capability just because there's not enough drift reduction technology built into it, because it is an SR series, which is finer. So the SR105 might not be ideal for that reason. There might be some applications that, being contact applications, that this would be an excellent nozzle, but in our case where we still need our drift fairly low, it doesn't satisfy the requirements. With that same size though, we could look at the MR105, same idea, 40 psi, down to 4% driftable fines, but our coverage factor is down to 76%. So that might be there. Alternatively, where the droplet size is closest to 400 would be at 60 psi, which might be okay, but you'll notice very quickly that our duty cycle drops. At the higher pressure, our duty cycle will be lower. So starting at 49% duty cycle is not ideal. Just because if we slow down at all, for an example, doing a turn at 9 miles an hour into a corner, we've pretty much hit rock bottom as far as that minimum duty cycle, and we don't really have much flexibility, despite having a coverage factor above 80% and keeping drift to a reasonable level. So there's less operating efficiency by using this nozzle. So all in all, we can be pretty confident that the MR104 might be the nozzle of choice for us. Again, just as a reminder, there's a little print icon which will only show in the web version of the app. Simply clicking it off will actually bring up this page, which you can just print off in the cab. So it kind of gives you the application information as far as what's involved, as well as the whole chart as shown before. Very handy to have in the cab, especially for first-time users, or if you're not the applicator itself in the cab as well. So it's kind of a nice resource for them, as it gives you, the percent driftable fines or whatnot, and notes can be made on the side as required. I hope that was fruitful for you. Otherwise, let us know if you have any questions. We're always here for you.